Okay, so now we're going to be multiplying polynomials, which the first thing we need to do is talk about the exponent rule. X to the a times x to the b is equal to x to the a plus b. So let me show you why that works on our first example. X to the 2 times x to the 4. Remember, exponents are just repeated multiplication. So x to the 2, that just means x times x. Whereas x to the 4 means x times x times x times x. And the fact that we're multiplying two exponents, which are basically repeated exponents, how many times am I really multiplying x? Well, 2 from the first one and another 4. So that's actually x repeated itself 6 times. Because exponents are just repeated multiplication, I can add the exponents, and that's a really fast way of doing this. So the next one example is x times x. There's an invisible 1 on both exponents. I have one copy of x plus another copy of x. So x times x is going to be x squared. X squared means x times itself twice, right? Or you can just take the invisible 1 plus the invisible 1 and get 2. Now the next one has a 4x times 7x cubed. So the 4 times the 7, that's going to get us 28. Now we're going to do the x's. X to the invisible 1 times x to the 3, that gets you x to the, add the exponents, 1 plus 3, and get 4. 28x to the 4. On the next one I have a 4a squared b times negative a to the 4th b, 7. Now there's kind of like a negative 1 there, so if I'm doing the coefficients, 4 times negative 1, and again this is the commutative property and associative property a lot here, but I'm not going to write it all out like the associative property. I'm just going to multiply the coefficients. 4 times negative 1 is negative 4. Then I'm going to multiply my a's, and the associative and commutative property tell me I'm allowed to do this. A to the squared times a to the 4, that's going to be a to the 6. And then the last one, the b to the invisible 1, b to the 7, that gives me a total of b to the 8, because I add the exponents. Okay, let's also, before we do some more polynomials, remember the distributive property. The distributive property says a times b plus c equals ab plus ac. So when you're trying to multiply polynomials, make sure you first use the distributive property and then combine like terms. Now when you multiply, you might have to use the exponent rule, which is why we just went over the exponent rule. So I have 2x times 3x. I'm going to distribute the 2x over the 3x minus 4. 2 times 3 is 6. X times x, remember we add the exponents and get x squared. 2 times 4 is 8x. Now I'm going to take the negative 6 and distribute that to its parentheses. Negative 6 times 2 is negative 12x. Negative 6 times positive 1 is negative 6. At this point, I'm going to combine like terms. The only two like terms I see are the x terms. Negative 8x minus 12 more x. When I add those, I'm getting negative 20x. The minus 6 comes down, and the 6x squared also comes down. So my final answer is 6x squared minus 20x minus 6. For the next problem, we just have one distribute here, one parentheses, and I'm taking 2x squared and distributing it all the way through. So 2x squared times 3x squared, that's 6x to the 4. 2x squared times negative 4 is negative 8x cubed. 2x squared times 1 is 2x squared. Notice when I'm multiplying the variables, I'm adding the exponents. On our next problem, we're going to be taking x cubed and distributing it through. The coefficient of the x cubed is a 1, so 1 times 4 is 4. X cubed times x squared, I'm going to add the exponents and get x to the 5. Minus, let's do it again. 1 times 3 is 3. X cubed doesn't have any other partners, so that just comes down. These don't combine because they're not like variables. The next example, I have 5x squared, distribute to x and 2. 5 times 1, the invisible 1 coefficient is 5. X squared times x to the invisible 1. I add the exponents, and there's 3. 2 x's from the first term times another x, that's a total of 3 x's. Plus 5 times 2 is 10, x squared times 1 is x squared. All right, now the 3x. Notice that the first time I distributed in red, it stopped at the end of the parentheses. So now I'm going to take the 3x in purple and distribute it to all of its parenthesis terms, okay? So 3x times 2x, that's 6x squared. 3x times negative 8, that's negative 24x. Now I can combine like terms. I see like terms on x squared. The first term, 5x cubed, doesn't have any partners, so it just comes down. 10x squared plus another 6x squared is 16x squared minus the 24x. And there's nothing else that can combine, so I am now done. Okay, so now we're getting a little tricky here. We have not just a monomial times a polynomial, we have a binomial times another binomial. 2 terms times a 2 terms. So the way we do this is we're going to take and double distribute. The 2x is the first term in the first polynomial, and that's going to distribute to both terms in the second parentheses. So 2x times x is 2x squared. Add the exponents. 2x times negative 4 is negative 8xy. Now I'm going to go back in green, and I'm going to grab the negative 3y. The negative 3y also has to distribute. I call this double distribute. Some teachers use the word FOIL, first, outside, inside, last, so if you know that one, you can use that. I like just to think of it as double distribute. It's the same as the monomials, we're just doing it twice. Negative 3y times x is negative 3. I'm going to write xy just to put it in alpha order. Commutative property says I can put it in any order I want, so I put it in alphabetical order so I can see the like terms easier. Negative 3y times negative 4y, and negative times a negative is a positive. 3 times 4 is 12, and y times y is y squared. I'm looking for some like terms. It looks like the 2 middle ones are like terms. That adds to negative 11xy. The 2x squared stays the same, and the 12y squared also stays the same. They don't have any like terms, and now I am done. Let's practice that again. Another binomial times a binomial. I'm taking the first term of the first binomial and distribute that. 4x squared times 2x squared, that is 8x. X to the 3 times x to the 3. Add the exponent, that's x to the 6. 4x cubed times 1, that's 4x cubed. Now I'm going to take the 5 and distribute the 5. 5 times 2, that's 10x cubed. 5 times negative 1, that's negative 5. I do see that my 2 middle terms are like terms. I have a negative 4x cubed and a positive 10x cubed. When I add those 2 like terms, I'm getting positive 6x cubed. The first and last terms stay the same. And I'm done there. Now we talked about adding polynomials, and we also talked about multiplying polynomials, in which we did some combining like terms as well. But sometimes people confuse the additive and multiplicative rules for polynomials. So I want to go over some common student errors so that you don't make those. For adding polynomials, the steps are add the coefficients and keep the common exponents the same. Whereas the rules for multiplying polynomials say multiply the coefficients and add the exponents. So I have some terms here that look very similar. So on the left it says 6x plus 7x. I'm adding the polynomials. So 6 plus 7, I'm adding the coefficients to get 13. What do you do with the variable and the exponents? Keep them the same. So 6x plus 7x is 13x. Whereas on the other side, when I'm multiplying 6x times 7x, you multiply the coefficients to get 42, and you add the exponents. There's an invisible 1 and an invisible 1 that gets you x squared. They're not the same. Let's try it again. 5p to the fourth minus 8p to the fourth. They are like terms because they both have p to the fourth. I add their coefficients, 5 minus 8 is negative 3, and keep the p to the 4 the same. But when I multiply 5p to the fourth times negative 8p to the fourth, I multiply the coefficients to get negative 40, and I add the exponents. P to the 4 times p to the 4 is p to the 8. Okay? Technically, these don't have to be like terms in order to multiply. They do have to be like terms to add, but I went ahead and just kept them the same just so you could see that they're different. The next one, y cubed plus 8y cubed. They are like terms, so we are allowed to add them. Don't forget that there's an invisible coefficient of 1 in front. That's what the multiplicative identity says. So I have 1y cubed plus 8 more y cubes. That gives me a total of 9 y cubes. On the other side, I have y cubed times 8y cubed. You can put the 1 there as well. But we're going to multiply the 1 times 8. 1 times 8 is 8. Y cubed times y cubed is y to the 6. So just be careful when you're confused, not to confuse your adding polynomial rules with the multiplying polynomial rules. And that concludes our lesson on simplifying polynomials.